Yes, sir.
Okay.
Yes, sir.
The first question is determine an expression for the following signal. Simplify your answer. Okay. In order to write an expression for this signal, you can break up the signal into two pieces. Two pieces, you know, like one of them. So this is the positive part of the signal going from 1 to 2. We call this x1t, the amplitude 1, and then you call this, then you call the negative part of the signal x2t. Let's say this is going from 2 to 3. Okay, okay, so let's say this is going from like 2 to 3. This negative peak is -1. So what we can do, we can write a separate expression for this individual signal. Okay, for x1t, okay, we already been through all this background theory earlier, right? Right, guys?
Yeah.
Hello?
Yes, sir.
So the first one, the first one, you know, you can write this as, this is a step signal that starts at 1 and ends at 2. So that is an expression that's going to give you this signal right here. Okay, guys?
Okay, sir.
Okay.
Okay, sir.
Yes. And the next one, x2t, is a signal that starts from u at time 2 and ends at 3. Okay, so this, so we have a minus sign here. So you have to include a minus sign here. Okay, minus sign. So I put a minus sign here is because you can see this is a minus sign, the negative 1, okay? So you have two different expressions for expressing the positive part of the pulse and the negative part of the pulse. And now just add them together. Now you add them up, you get a u t minus 1 minus u t minus 2, and then you plus the other signal. The other signal, we have a negative sign there, right? So add the negative part of it, u t minus 2 plus u t minus 3. Then next you open up the parentheses and add them up. Okay. So now you see, once you add them up, you can see these two terms are the same terms. So you can see these two terms are the same terms, so you can just add them up. So the final answer is going to be u t minus 2, and then that's going to be the one that I've underlined in red. There are two of them, so it's going to be minus 2 u t minus 2 minus u t minus 3. So this is the, okay, so that is the answer. That's the expression that you want. Got any questions? Okay, now I know you maybe e to the j 25t. Okay, is this periodic? To be able to identify this, can you see the signal, the format of the signal? This is an exponential function, and there's a imaginary part, and there's a omega, and there is a t. So the omega, what the omega is telling you, there's a frequency. If there's a frequency, then there's going to be a period, right? You can see from the signal here, from this relationship between this and this frequency. If there's a frequency, there's a period. If there's a period, that's going to be a frequency for repeating signals. Okay, so can somebody tell me what is the frequency? Frequency is
1 over time.
okay. What is the frequency in this problem? Value
25 t.
25
25.
radians per second. Okay, so since this is the only frequency in this signal, there's only one frequency, so this is going to be periodic. This is just a one simple signal. There's going to be like a periodic, right or not? Like for example, so this, what is the period? Period is going to be period 2 pi over, period is 2 pi over omega, right?
Yeah.
So this is the period from year to year. That's a period t. Okay, only the problem only starts, the analysis parts gets a little bit complex when you have more than one signal with a different frequency. The next problem is when you have xt is equals to problem B. Xt is equals to cosine 4t plus sine 3t. Guys, by the way, is my voice loud enough?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we have a signal here. A signal that is composed of two other signals with two different frequencies. So for example, this is, you can call this omega 1 and you can call this omega 2. When you add these two signals, the question is, when you add them up, are they going to be periodic also? So we don't have a software tool that we can plot and we can visually tell. But since we don't have the software, so we're going to do this analysis to find out, to determine whether it's periodic or not. And this is how you do it. Corresponding to omega 1, there's going to be T1, period 1. Period 1 is 2 pi over omega 1. Okay? And that's going to be 2 pi over omega 1, in this case is 4.
4.
4.
Which is going to be pi over 2 seconds. Corresponding to omega 2 is going to be period 2. Period 2 is going to be 2 pi over omega 2. It's going to be 2 pi over 3. Sorry, this is not seconds. This is, yeah, this is seconds. I'm sorry. This is in seconds. So what we do now to determine whether they are the sum of these two signals are periodic or not, this is the procedure. we try to take the ratio of these two periods. It can be T1 over T2 or T2 over T1, it doesn't matter, okay? So T1 is pi over 2 divided by 2 pi over 3. Pi over 2, 3 over 2 pi. Can cancel this. 3 over 4. So this is what you get. This is you are getting a fraction. In this fraction, note something. The numerator is an integer. The denominator is also an integer. Integer. So integer divided by integer is a rational number. It's a rational number. It's a rational number. So this means it is periodic. Okay, now how do we find the period? T1 over T2 is 3 over 4. So only when there are two signals involved, the procedure is quite straightforward. Cross multiply, we get 4T1 is equals to 3T2. And that's equals to the fundamental period. So what's the fundamental period? It can be either 4T1. What was T1? T1 was pi over 2, right? It can be, either way you will get the same answer. Even 3T2, T2 is 3 multiplied by 2 pi over 3. So this also gives you 2 pi. This also gives you 2 pi. So this is the fundamental period. Fundamental period is 2 pi seconds. So any questions? Why is it disconnecting me? I think it's doing that after 40 minutes. So you have a signal that is composed of 3 other signals of different frequency, omega 1. See, whichever number that's multiplied to t is the frequency in radians per second. Again, you can see, you can identify the frequency here. It's omega 3. Okay? All right?
Yes, sir.
Hello?
Yes, sir. Yes,
Okay.
we can hear you, sir.
Yes, sir. Can hear. Can hear.
So I'm just getting worried, you know, if you guys getting disconnected or something like that. That's why I'm trying to ensure that you are around. So from omega 1, you calculate your T1. T1 is 2 pi over omega 1, right? Which is going to be 2 pi over 3. Okay, so T2 is going to be 2 pi over omega 2. Is 2 pi over 4. Is equals to pi over 2. T3 is going to be 2 pi over omega 1. Sorry, it's omega 3. 2 pi omega 3 is 5. So we got three different periods. We got three different periods. Yeah. Yeah. Periods are usually in seconds, you know. So make sure. So we have three different periods. So how are we going to do this? There's a couple of ways to do this, but you know, there's one way you can just choose one of them as your reference period, and then you compare the other two periods with this reference period. Let's say if I choose my T1, choose T1 as my reference. Okay, that means I'm going to compare T2 and T3 with T1. And by comparing, that means I'm going to evaluate the ratio to find out if they are going to produce rational numbers. So let's do that. So let's first compare this, take the ratio of this. Let's take the ratio of T1 with this, okay? Then next I'm going to take this is the first one. Then I'm going to do the ratio between these two. So let's do T1 or T2. T1 over T2 is going to be 2 pi over 3. 2 pi. So let's allow me to go to this in detail. So okay, T1 is 2 pi over 3 divided by T2, pi over 2. It's going to be 2 pi over 3 multiplied by 2 over pi. So that's going to give you 4 over 3. So this is a rational number, rational number. Okay, so I'm going to do the same thing with, if this ratio is not the rational number, you can right away say they are not periodic, okay? But since they are rational number, I'm going to check the other pair. T1 over T3. So it's going to be T1 is 2 pi over 3. T3 is going to be 2 pi over 5. So that's going to be 2 pi over 3 multiplied by 5 over 2 pi. So that's going to give you 5 over 3. So that's a rational number too. So, okay, so we have two rational numbers. And then if you note very carefully, these rational numbers, the two rational numbers have same denominator. Please note this. Okay. So you can say the LCM, the lowest common multiplier is 3. The lowest. So therefore, the lowest common multiplier, or in short term, we call this LCM. LCM is 3. Okay, this is the procedure. This is how we do it when you have 3 signals, when you have 3 periodic signals. So the period is going to be T is just going to be 3 T1. 3T1. Okay. 3. What is T1? T1 is
2 pi over
2
3.
pi over. Okay. This is 2 pi over seconds. 2 pi seconds. Or you can just you might be wondering, why 3T1? Of course, we know this this LCM is 3. Why 3T1? Of course, you also can multiply with the others. Like, for example, T1. Let me do this in another color. You also, for example, you know that T1 over T2 is 4 over 3, right? So that's going to give you 3T1 is equals to 4T2, right or not? You already use 3T1 right there, yeah? 3T1. You also can say, okay, T can also be 4T2. 4 multiplied by T2. What is T2? T2 is pi over 2, right?
I over 2.
Pi over 2. So that also going to give you the same answer. Okay. The most important thing is to identify the LCM. Identify the LCM. Thus the periodic. Thus it is periodic. It is periodic with T is equals to 2 pi seconds. So that is the answer. So this is just to show you that these two guys are giving you the same answer. This and this also giving the same answer, the one in blue. Anyway, let's move on. Got any questions here? This is part C. Part D.
No, sir.
Okay, let's. Is anybody tired yet?
No, sir.
So,
Even you got the drink. So you can have a drink. You can drink while watching this. I mean, I'm not talking about that drink.
So I got one question.
Maybe you can ask your mom to make coffee or tea. That's what I meant.
No question, sir.
Okay. Huh? No question. Okay.
No
Thank
question,
you.
sir.
So let me proceed with the next one. A D. A D is also kind of same kind of a problem. Here we have rational number. Okay, so we have the similar 4 cosine 4t plus 3 e to the minus j 12t plus sine 4t. Okay, and again we have 3 different frequencies. So whichever number that's multiplied to t is the frequency. So that's a frequency. Frequency 1, frequency 2, frequency 3. So for each frequency, if you evaluate you will get T1 is 2 pi over omega 1 is equals to 2 pi over 4 equals to pi over 2. Then T2 is going to be 2 pi over 12. And that's going to be, you don't you don't take the negative here. Frequency is positive. So you just use the positive part of it. Pi over 6. All right. And then if you note carefully, we don't need to evaluate this. We don't need to find the period of this, right or not? Do you know why? Because omega 1 and omega 3, they are the same, right or not? Omega 1 and omega 3, they are the same, right?
Yes,
Right.
yes. Yep.
Yes, sir.
It's also T3. Okay, so that means we only have to compare two of them, which is T1 and T2. So as usual, we take the ratio of these two, T1 over T2, or T1 over T3, or whichever. Sorry, these two are the same. T2, note, T1 is same as T3. We just consider one of them, T1 or T3. So T1 is pi over 2. And then T2 is pi over 6. It's actually my nap time, I'm kind of keeping myself awake, usually 3 o'clock. But today is, today is a working day, so we cannot take nap. Usually weekends, 3 o'clock is favorite nap time. Pi over 2 is 6 over pi.
Same, sir.
Okay, so it's 3 over 1 is a rational number. So again, now in this case, what we do here, we just do the cross multiplication. We had something like this before when we had only two. Earlier on, remember, we only had two signals. Where was it? Okay, remember in this case, we only had two signals here. I remember. Same deal, okay? So the period is, we cross multiply, T is equals to T1 or 3T2, right or not? And that's going to be pi over 2. Is that okay?
Got it, sir.
All right. So we have one more on to go, like one more example on this category. This is kind of a little bit confusing, but if you guys analyze this closely, not this problem, we are not done with problem number 2 yet. Number 2, there's one more, E, part E. Then the sinusoidal part, no problem, right? We have 3 signals. The sinusoidal part, we have no problem. We have seen this before, right? So anything that's multiplied with T is omega 1, right? Okay, then this one also sinusoidal part. So like this is, we look, guys, there are 2 parts here. This is the phase. Okay, so this part here, this is the phase delay, I would say. Phase can be a phase delay, or can be I just call this phase for a while. In this part here, it's also phase, but then it's multiplied by frequency. Okay, call this frequency 3. So from the first term and the last term, this is the first term and the last term, we know the frequency, no problem, right? Right or not? From T1, like for example, T1 is what? 2 pi over 3 pi, right? No problem. Straightforward. Sinusoid. So T3 called T3, which is right. So what's the period here? 2 pi or multiply by 6 over pi, right? So that's going to be 12 seconds. So T3 is 12 seconds. T1 is 2 over 3 seconds. Then what about this? So we already know this. Okay, no problem. We also know this. We put this in a different color to make it more attractive. Okay, let's, what color do you want, G? Okay.
My lucky color blue.
Too late now, you tell me. T3 is also okay. Now what is T2? How do you find T2? It's very easy to find. It's 1. Do you guys see that? This is the discrete signal. Like the signal is going like this. For example, maybe I have to draw a little bit to show you that. Discrete signal. Okay. The interval between is 1, 1, 1. Okay. This period is 1. After every 1, another signal comes in. So T2 is 1. Okay. So now what we do the same thing as we did before. We can choose any one of them as our reference period and compare others. Okay. So if I choose, for example, choose T1 as your reference. Choose T1 as your reference. Okay. So that means I'm going to compare one by one. So I'm going to compare with this. So T1 over T2. T1 is
2 over 3.
okay. T2, 1.
1.
So rational number. Okay. So let's do the comparison with T1 over T3. T3 is how much? 12, right?
12.
12.
Why there's an echo? 3. 2 over 36. It's 1 over 18. Also rational. also rational number. Okay, guys, any problem so far?
No,
So far,
sir.
okay, sir. So far, okay, sir.
Okay, sir.
Okay. And then, so what do we do next? Remember when we had 3 signals earlier, when we had, when we do the
Sir.
ratio, okay.
Sir, before we move on, why was T2 chosen as your reference? What if T2 was 2, for example?
T2 is a 2.
Let's say
If
T2
T2 is,
was 2, would it be?
you asking why I choose a T1 as a reference?
Yes. Yes. What if it was T2? I mean, what if T2 was 2, for example? Would it? Yes.
If T2 was 2, then you put 2 here. If T2 is 2, then you just put 2 here. Hello?
Okay. Yeah. Yes. Okay.
Okay, you can try to, see right now you choose you choose this as your reference, right? You can
Yes.
try choosing T3 also as a reference. You get the same answer. You can
Okay.
verify this next time. We can try this.
Okay.
And yeah, you can do, maybe the next time you do it by choosing T3 as a reference. I just to choose T1 because T1 is the first one.
Okay. All right.
Okay, does that help?
Yes. Yes.
Good question. Good. Very good. There's somebody asking question is very nice. All of you guys, you should ask question, only the questions that I know. Okay, guys, so after you do this T1 over T2, after doing this, do you remember how you solved this problem after doing this? Do you remember we had a similar problem here? Excuse me. I'm also coughing, but there's no one in this room, no problem.
LCM.
Okay. Then we know this problem. Remember when we had 3 different frequencies, like which one was that? Okay, see, remember? We had similar problems. So we choose our LCM to be 3, right? Okay. Remember, we choose the LCM as 3.
Yes, sir.
Okay. Now what is going to be my LCM in that problem? What is going to be my LCM? Compare these two and tell me which one is LCM. 18 or 3?
3.
Sorry, no, it's supposed to be 18. Okay, problem, we find the energy in the following signals. So before you can find this problem, find this energy, you have to draw the signal. Only after drawing the signal, you can get a clear idea of the integral limits. So it's okay, it is always better, but if you want to do without sketching it, it's okay, but then if you get the wrong answer, then problem. So it's a good idea to sketch it. For example, A, xt is equals to 3 u t minus 2 minus u t minus 5. Okay, so find the energy in the following signals. It's quite easy. All you have to do is sketch the signal. You know how to sketch, right? The amplitude of the signal is 3. This is the amplitude of the signal. 3. The signal, it's going to be starting at 2, at time 2, and it will end at 5. Start at 2 and ends at 5, 2 to 5. That's it. Now this is time axis, and this is the amplitude, signal amplitude axis. Energy formula is very easy. Energy formula is the integral from minus infinity to positive infinity, and then the signal amplitude squared. The signal is negative, it becomes positive because it's amplitude, and it's squared again. So, but our limit doesn't go from minus infinity to positive infinity. Our limit is 2 to 10.
2 to 5.
Beg pardon? So the integral is from 2 to 5.
5.
My notes, I got 10. For some reason, it's a mistake. 3 squared. Okay. 3 squared dt. Then you integrate it. 2 to 5, 9 dt. E 2 to 5. So 9, 5 minus 2 is 27. So when you get a finite, and you're getting a finite answer. Finite. Since you're getting a finite answer, therefore it is an energy signal. It's a 27 right now. It's unitless. Depends on the problem. It can be joule, kilojoule, or Newton. Depends on the real life problems. For now, it's just a number. It's a finite number. If you know how to integrate, if you know how to sketch this, no problems. You can do it. The next problem also xt xt is t squared xt is t squared ut u t minus 3. Okay, here the thing is, this is the signal. This is the signal. This is really the signal part. This gives you the integral limit. The integral limit. You want to sketch this, like this is just a parabola, right? T squared, y is t squared is just a parabola. For example, if I sketch this here, this is just going to be, if I sketch it the way it is, okay, this is xt, and this is t squared. This is just a parabola. But what is this part is doing? So what is the step function doing? It's just giving you the limit. Just it's amplitude 1, right? It's just telling you you only integrate the signal is on when t equal to 0, and the signal is off when t is equals to signal is off when t is equals to 3. Okay, that means the signal doesn't exist outside this limit. You know, signal only, you only integrate, signal is on at 0 and is turned off at 3. Technically, the signal is going to infinity, right? Minus infinity to positive infinity. Do you guys follow?
Yes, sir.
Yes, sir.
All right. Okay, now you have all you have to right now, you just integrate energy, definition of energy, minus infinity to positive infinity, signal amplitude squared dt. This is going to be from 0 to 3, right? That was defined by the step function. The sketch is just a rough sketch, just to give you an idea. The step function is like a switch on the signal at 0, off the signal at 3. So it's t, the function is t, that's a signal, t squared, squared. Okay, that's 2 squared here. This signal as itself as a squared, t squared, dt, 0 to 3, t to the power of 4 dt. Then you evaluate the integral, get out of here. T515 t to the power of 5, right? And then you evaluate from 0 to 3. Correct? Uh, 243 divided by 5. There is the answer. So you see that's a reason for plotting this. But you know, you can also do this if you can see with your mind that what's happening. The step function is just like telling you the limit of the integral, lower and upper limit. So you know the lower 0, the upper limit is 3. You don't have to sketch it if you know. Okay. Can I go to the next one?
Yes, sir.
So in the problem, so this you have to understand this discrete signal really well, because when you go to DSP, you'll be in a good shape. So before we can work on this problem, we try to separate the constant terms from the k-dependent terms. So you look at 1/3 is same as 1/3 to the power of k multiplied by 1/3 to the power of 1. In that way, you can separate the constant terms from the k-dependent term. So you can pull out the 1/3 and put together all these k-dependent terms. Okay, what this part, this is just like the amplitude part, you know, this is just like a constant number, constant. And this is the k-dependent. What is this doing? This is just telling you that you k minus 5 is equals to 1 if and only if k is greater or equals to 5. That's what he's telling. Okay. Can you guys follow? Hello?
Yes, sir.
Yes, sir.
We can
Are
follow.
you
Sir.
guys are
Yes,
sleeping
sir.
or okay? Then therefore I can rewrite the energy as E 1/3. I can just rewrite this formula as this this signal as 1/3. Okay, let me go to the basic definition of energy. Energy formula for digital energy in signal. We had a different formula for continuous time signal. Energy in a discrete time signal E, we have a different formula here. It's just instead of integral, you cannot integrate. Excuse me. You cannot integrate a discrete time signal. So we have to sum it. K is minus 8 to A, minus infinity to positive infinity, amplitude xk square. Okay. Now you have to square all these things. You have to square this. You have to square all this. Okay, square it. So what do you get if you square it? E is equal to summation k is equals to minus infinity to positive infinity, the square over 3 k. This you cannot square because as I said earlier, this is only defining the interval. So the square only applies to this. When you square, you only square this. Okay. All right. Okay.
Yes, sir. Okay.
Got it, sir.
Okay. That's one thing I'm going to do here. Instead of starting from minus infinity to positive, instead of going from minus infinity to positive infinity, I'm going to go from k is equals to 5 to infinity. Okay. This, but I'm not going to write this. See, this part here takes care of this. Do you guys see this? Okay. Okay.
Yes, sir.
Got it, sir.
So 1/3 squared is 1 over 9, right? Okay.
Mhm.
1/3 to the power of k squared is going to be 1 over 3 2k, right? Am I right?
Yes. Correct.
Yes, sir.
And again, I would like to stress that you don't have to do this because this has been taken care here. Okay. So after this, what are you going to do? Again, you have to put, you want to make sure that you put them in a standard form. You want to put them in a standard form. You will see what I'm trying to do. Okay. K is equals to 5 to infinity, 1 over 9, 1 over 9, and then I'm also can do this. So it's going to be 1 over 3 squared to the power of k, right? So this is going to be so you can pull this 1 over 9 out. Then inside 1 over 9 to the power of k. We move to the next. So how are we doing? How are we doing?
Good, sir.
It's good.
Okay. So then how are you going to evaluate this? This is going to be as k varies from k equals to 5 until infinity, you're going to get a series of numbers. How are you going to solve this problem? Let's see. 1 over 9. So when k is equal to 5, what happens? 1 over 9 to the power of 5. When k is 6, you're going to get 1 over 9 to the power of 6. When k is 7, you're going to get 1 over 9 to the power of 7. And it's going to go on. It's going to grow up. It's going to grow up. The number is going to go up as k increases. Okay. There's a formula to solve this problem. I already have this in the notes in detail. I'm not going to, if you want to know how we be in other mathematics, if you know how to solve this problem, in order to solve this problem, there's a formula that you can apply. Sum of infinite geometric series. Okay, let me continue with this. So next, what I can do is I can factor out the 1 over 9. See, if I take out the, are you guys around? Okay.
Yes.
So if I factor out 1 over 9 to the power of 5, okay, and then I'm going to get 1 plus 1 over 9 plus 1 over 9 squared plus 1 over 9 cube and plus dot dot dot. Okay, let me simplify this further. If I multiply this two, what I'm going to get? It's going to be 1 over 9 to the power of 6. And then Okay, this part here, like this part here, you can replace this part here with a summation. K is equals to 0 to infinity 1/9 to the power of K. See, you can see when K is 1, when K is 0, you get 1. See, when K is 0, you get 1. When K is 1, you get 1/9. When K is 2, you get 1/9 squared. And K is 3, do you see?
Yes.
Do you guys see?
Yes, sir.
Yeah. So therefore, I can just replace the series of numbers with this summation. Okay, after doing this, the reason for doing this, let me move this. Okay, the reason for doing this, guys, now I can apply after the now I can apply the sum of infinite. I can apply this formula. This formula can evaluate using sum of infinite geometric series. And this is the formula. And we have this formula from the last time. I don't know if you guys still remember. We have this formula in the notes. It's the formula, sum of series, sum of infinite geometric series. Geometric series. We also studied this formula in mathematics 2A. The sum of geometric series A times to the power of R to the power of K is equals to A over 1 minus R. Okay, so using this formula, we should be able to evaluate and solve our problem. So if we compare this formula, we compare these two. We compare these two. This part here, this is part. We compare these two, then what is going to be R in this case? R is 109, right? Correct. A is 1. A is this one is in it, it's a 1 there. Okay. Are you guys around?
Yes, sir.
Yes, sir. Yes.
Hello?
Yes.
A is equals to 1.
Yes, sir.
There's somebody, Sardi's voice is very soft. Sardi, you just came on.
No, sir.
Okay.
Funny guys.
All right. So you just use this formula, and then we can solve the problem. So therefore, now energy is 1/9 to the power of 6. Using that formula, A is 1. A is 1. I'm looking at this formula here. And then we also know of A and R. So A is what? A is 1, right?
Yes.
A is 1, isn't it? A is 1. Then what is R? R is 1/9.
Yes.
Okay, so that's going to give you 1/9 to the power of 6. And then 1 minus 1/9 is 8/9. 8/9. So that's going to give you 1/8. 8. And then, you know, one of them can cancel with this. I mean, sorry, one of them can cancel and this becomes 5, right? Okay.
We got class, you know.
What day?
Wednesday, sir.
Wednesday 2 o'clock, sir.
Wednesday, sir.
Wednesday 3.
The Wednesday 2 da.
Time?
2
Wednesday
2 p.m.,
2
sir.
o'clock, sir.
2 p.m.
2 p.m.
Wednesday 2 p.m.
Wednesday 2 p.m. What's the date on Wednesday?
1st April, sir.
4th April.
1st April.
I got to.
So guys,